All right, today let's take a look at some of the behaviors of waves. Pay attention to the vocabulary because this is where kids get a little bit mixed up on what means what. So we're going to first talk about reflection. Reflection occurs when a wave strikes an object and bounces off of it. All types of waves, including sound, water, and light, can be reflected. How does reflection of light allow you to see yourself in a mirror? Well, it happens in two steps. First, the light has to strike your face and then it bounces off. And then the light reflected off your face strikes the mirror and is reflected into your eyes. There is a law of reflection. We have a couple of things that we've got to get explained here. We are going to draw a perpendicular line to the surface of the mirror called the normal. And so here is the law of reflection. This is the law here. You might write that down as the law. The angle formed by the incident beam and its normal is called the angle of incidence. And the angle of reflection is the reflected beam. And then here's what the law says. They are indeed equal. So let's watch a quick little video that demonstrates this. And it's quiet, so. And the normal is here. I think they're trying to make it look like a magic show. Of course, it's not magic, it's science. Now, do you see what they're also showing refraction here? You see how the angle, once it hits the glass, changes the angle of incidence? So what you have is that the angle of incidence is equal to the angle of reflection. And of course, those angles are measured by the normal. So here's a normal, here's the mirror, and this would be the angle you're talking about. This angle and this angle. Not here. Nope, nope, nope. Okay, so that is the law of reflection. Now, what we saw in the second half of that video was refraction when they put a piece of glass. Do you see what this looks like right here? You see how that pencil looks broke or fractured? That is refraction. It's the bending of a wave caused by its change in speed from going from one medium to the other. So light travels a certain speed in air, and then it slows down when it's in water, and that's what changes that the appearance of the pencil. And so here you see a drawing of that. Here's your normal. And then this is the angle you would predict the light to travel in, but it doesn't. It tends to bend closer to the normal. And so, again, if you're doing the opposite, going from water to air, it's going to bend away from the normal. Again, objects underwater do seem to be closer to you, so than where they actually are, and so that's just a trick that the light waves are having on you. So we've had reflection, refraction, and now we've got diffraction or diffraction. When waves strike an object, several things can happen. The object, the waves can bounce off or be reflected. If an object is transparent, light waves can be refracted as they pass through it. And waves can also behave another way. They can bend around an object, and that is called diffraction. So bending around an object is diffraction. And so so both diffraction and refraction cause waves to bend. So summary, wave behavior, you have reflection, which is the bouncing back, and the angles are equal to the normal, and refraction, which is bending, and diffraction, which is also bending. And then we've got absorption, which is moving through. We're going to take a look at standing waves on our next journey. This will be all we'll do today on notes.